Hello and welcome to the topic of brake fluid. Today we're going to discuss some of the differences between different fluids and what can happen to brake fluid over time. The brake fluid needs to be designed to withstand low temperatures, high temperatures, and have lubricating properties. Most systems are glycol based. So most systems use .3 brake fluid, maybe .4. A lot of modern vehicles are specified to use .4 fluid. The main difference between different types of brake fluid is going to be mostly between boiling temp. In a sealed hydraulic system, boiling point is going to be one of the major factors. As heat's generated at the brakes during normal operation, the heat generated by the brakes is going to transfer through the materials, through the calipers, through the vacuum plates, into the lines, and end up heating the fluid. If it were to boil or vaporize, as that vaporizes, those air pockets can be compressed. So with steady pressure on the brake pedal and the fluid turns to a vapor and compresses from that point, the pedal is going to start sinking down. This is what we call brake fade. Brake fade can lead to possible loss of control of a vehicle, inability to stop or slow down. The brake fluid has to maintain its properties and resist vaporization under normal conditions for the safety of the system, for the longevity of the system. So we start with .3 brake fluid. This is one of the more common ones. It's what most older vehicles are required to use. .4 has a higher boiling point. Now these two can mix together. If these two are mixed together, the .4 boiling point becomes the .3 boiling point. The .3 boiling point does not raise to the .4 spec. The .4 spec goes down to the .3 spec. So for example, .3 brake fluid has a boiling point of 401 degrees Fahrenheit compared to .4 that has a boiling point of 446 degrees Fahrenheit. So almost a 50-degree difference in boiling point from .3 up to .4. There is a special type of .4 fluid made for racing applications where brakes are going to be under a lot more abuse. So they're going to be generating more friction and consequently more heat. It says right on the bottle here, boiling point 536 degrees Fahrenheit. So quite a bit higher than the 446 degrees of standard .4. This one is actually dyed with a blue dye to help indicate what type of fluid it is. Flushing and complete mitigation of the old fluid is important, so we don't reduce the performance of any fluid that we are introducing to the system. .5 brake fluid is a silicone-based fluid, and it is dyed purple, another visual indicator to help identify what type of fluids in the system. .5.1 is not soluble or miscible with .5. This is another glycol-based fluid, much like our .4, .3, and the Super Blue Racing .4. Its boiling point is 500 degrees Fahrenheit. Now the thing that's going to change the boiling point is the introduction of moisture into the fluid. So these that are glycol based, so we have .3, .4, Super Blue, and 5.1. These are all glycol based fluids. These fluids are what are referred to as hygroscopic fluids. Hygroscopic means that they have an affinity towards water. They will absorb moisture from the environment. As more moisture is absorbed into the fluid, that boiling point is going to come closer to that of water. So if our boiling point of water is about 214 degrees Fahrenheit at sea level, and we introduce it to a fluid that has a 500 degree boiling point, as more water, or as the percentage of water increases in the fluid, that boiling point is going to go from 500 and approach closer to 200. So our performance of the fluid is going to decrease. There are many people who do choose to do their own maintenance, and part of that maintenance, people like to do brakes. They seem simple enough, but the more you understand about brake systems, the more complicated they are, and they are the #1 safety item on a vehicle. So it's possible that somebody may not understand the differences between some of these fluids and introduce the incorrect fluid to the system. If we were to introduce a silicone-based fluid or a mineral-based fluid, mineral oil fluid, into a system that is designed for glycol, any of these glycol-based, that could potentially cause the seals in the system to swell. If we have swelling of any seals, they can weaken, they can tear, they can rupture, and worst case scenario, they can cause seizure in the system. They can swell to the point where they don't let the two moving components move with respect to each other, essentially locking the system mechanically. Each fluid having a boiling point specification actually has 2 boiling points. There's one that is referred to as the dry boiling point, and the other boiling point is known as the wet boiling point. Dry boiling point versus wet boiling point. What does that mean? The more moisture we have from the atmosphere, the lower the boiling point. So that's measured in terms of percentage. The higher the percentage of moisture content in the brake fluid, the lower the boiling point. So when we reach our low boiling point spec for the fluid, regardless of what type of fluid it is, it will have a dry boiling point and a wet boiling point. Dry boiling point means when you open the container and it is sealed, that fluid has not been introduced to moisture. It is therefore considered dry. The boiling point decreases until it reaches its wet boiling point specification for that fluid, at which time that fluid needs to be serviced and replaced with new fluid. Fluid that has absorbed moisture will continue to absorb moisture over time, and that boiling point will continue to decrease. Here is a visual representation of what this looks like. In this graph, we have boiling point versus time, and in this graph, it is hygroscopicity versus time. So our time is measured out in months. We go from 0 to 16 months down here on both scales. Hygroscopicity is measured in percentage from 0 to 2%, and temperature over here goes from 200 degrees Fahrenheit to 450 degrees Fahrenheit. We just replenished brake fluid in the system. We have complete dry boiling point specifications. As time moves on, that boiling point is going to decrease because our fluid is going to absorb moisture. A typical brake system with glycol-based fluid will absorb about 2% of its volume within a year. Some things that may change this is environmental humidity. In the Northwest, we have a pretty humid, wet climate with the rain that we have. That will contribute to increased amount of absorption within that year. Places like Death Valley or the Mojave Desert, some of the more dry and arid regions, is going to slow the absorption down. So this is a general idea, but it shows the relationship as more moisture is absorbed into the brake fluid, the boiling point decreases over time. It absorbs more right from 0%, its absorption is going to be faster. And then as time continues, that absorption rate is going to slow down as it continues on. So that is also reflected here in our boiling point. As absorption slows down, our boiling point will decrease rapidly and then less rapidly over time. Even without breaking the seal on the cap of a container of brake fluid, it can still absorb moisture through the plastic. So if you have brake fluid sitting on the shelf for multiple years, there is a possibility that it has a shelf life and can no longer be used in a vehicle. If you're unsure, it needs to be tested. Some differences in containers can be between plastic and metal containers. One of these is going to cost more to produce. Any guesses? Well, if you guessed metal, you're right. It's going to cost more to protect that fluid in a metal container. That moisture is not going to be able to pass through a metal container. It can pass through a plastic container. So this is for a racing application. This is for daily use application. This will definitely cost more money than its .4 counterpart. The difference in shelf life from a plastic container glycol-based fluid compared to a glycol-based fluid in a metal container, if it's sealed and has never been opened, this will have about a 5-year lifespan, 5-year shelf life. This one would have about a 2 to 3 year shelf life. Things that we always want to check: does it have a fresh new seal? If it's opened, it's not worth using. We don't know the condition of that fluid or if it's been contaminated. So new fluid should always be used for each brake job that you do or each time you service the brake system. If you have a reserve of fluid, so you didn't use all of the fluid during one job and you have some left over, it's best to use that fairly soon after doing that job. Either service the system to the point where it uses all of the fluid for that size of container, or save that for something else that you will use, maybe for topping off fluid. In order to know the condition of a fluid, we have to do a few tests. There are multiple ways of testing moisture content in brake fluid. There is a little bit of a hang-up in that process though. Most of these fluids are water soluble, so it absorbs moisture. As moisture increases in that fluid, it will start reacting with the brake system components, with the seals, with the inside of the lines. The inside of the brake line has some copper in it. So the copper is there to reduce corrosion, be resistive to corrosion and other problems. And as that moisture content increases inside the fluid, it's going to strip away that copper lining on the inside of the brake line, whether there's steel line or the nickel copper, often referred to as NICOP brake line. The inside lining gets stripped away and that starts to mix itself into the fluid. There are a couple methods that we use to test the moisture content of fluid. So our examples of some brake fluid. In this container is .3. It's a clear amber color. Here's .4. Very similar in color, just different specifications as far as boiling point goes. And .5. Very different color, very bright, vibrant purple. .5 application fluids may be used in things like motorcycles where you can have some spillover and it gets onto cosmetic surfaces, rather than inside of the engine compartment of a vehicle where it's not as cosmetic, you're not seeing things. .5 silicone based fluid is not going to eat away at painted surfaces. However, brake fluid, most brake fluid is glycol based and it is very corrosive to painted surfaces. So if this gets onto any painted surfaces, it needs to be cleaned immediately. If you're working around painted surfaces, they should be covered and protected from any potential fluid getting onto them. Other applications for .5 brake fluid. Since this is a silicone base, it does not absorb moisture. So boiling points for this one are hypothetical. There is a vaporization point for this fluid, but the wet specification is essentially made up because water will not mix with silicone or mineral oil brake fluids. One of the applications for .5 would be, other than a motorcycle, might be a classic vehicle, a classic vintage car. And if the owner of that vehicle replaces the seals in the system to where they are compatible with .5 brake fluid, then this can be run in there and you don't have to worry about it absorbing moisture over time and having to continually replenish that fluid and service the system. Testing the fluid. There are a couple common ways that this fluid is tested, that brake fluid is tested. One of which are the copper dip strips. So there's a container, I don't have it here, It's a little canister with a cap on it, and it has little test strips in it. And you dip the test strip into the fluid, and there's a little patch on the end of it, almost like a felt. And that patch will change color. It'll start from the pale range, and depending on moisture content, it will darken to a darker hue of purple. This is measuring copper corrosion level in parts per million. So it's not actually testing moisture content. It is using the copper that is suspended through the fluid, indicating that there is moisture in the system, and it has stripped some of that copper from the inside of the brake system, from the linings. And that is what is reacting with the test strip. Right about here, there's a change in the scale that specifies when your service is due, or when your fluid is due for service. So this would be okay, okay, marginal, marginal, service required, service required. So depending on what your test strip shows, it gives you an interpretation of how much moisture there is in the system. Another common way of testing these is with an electronic tester. These electronic testers have a cap on the end, and they have two electrodes coming out. These are battery powered. There's a button on top, and it lights up green to let you know that you're ready to test. The way to use these, and we'll test DOT3 fluid right now. The way to test these is to turn it on, and then dip the electrodes into the water, into the brake fluid, and do not fully submerge the tip. So the base of those electrodes are sticking out of the fluid a little bit. It's just the tips that are in the fluid. Now this is measuring conductivity between conductive particles in the system. So what's conductive in the system that would be in brake fluid? Copper. Copper particles, once again, are being used to determine the moisture content of the fluid. So with this fluid, this fluid is measuring over 4%. And I don't have the test strips to compare that to, but there is another method for testing brake fluid that's a little more accurate. An alternative method to testing this is actually testing for the boiling point of the fluid that's in the vehicle or in the system. Here's a tool made by OTC called the Brake Fluid Safety Meter. So this will be submerged into the fluid and heat the fluid, and when that boiling point is reached, it's going to record that temperature, and you'll know exactly what the boiling temp is of your fluid. There's no calculating through parts per million of copper or conductivity through the fluid using copper as the conductivity source. This actually tests the brake fluid boiling point. I've had fluid brand new out of the bottle fail on the electronic tester, indicating that there may be some other stuff in the fluid that conducts between those electrodes. And I realized that I was selling a lot of brake flushes or brake fluid services for fluid that was due for service, when really the tool might have just been reading the wrong thing. So let's go see how to use this. For this example, we're going to be working on my 1978 Jeep CJ5. So let's take a look at a couple of things here. Here is our master cylinder. It is very rusty. It did not come painted, and I didn't paint it. Below that, I will show you on this steering shaft right here. This is actually used to be painted, and you can see from brake fluid leaking, it has stripped that paint off. So there's where it was painted. This is below the master cylinder. And then right here on the engine mount, kind of hard to tell with the sunlight right there. Give it some shade. that paint has bubbled up and is now exposed because brake fluid got onto it and stripped the paint off. I have this hooked up to the positive and negative post terminals on the top of the battery. I have the cord coming over here to the tool, and the tool is reading battery voltage, and it's prompting me, apologize about the light here in the sun, battery is at 12.6 volts. So we have a fully charged battery, we're ready to test. So with our master cylinder open, we can test the fluid directly in the master cylinder. So the switch on this tool is located right up here as a button. That no hand, no touch means this is going to get hot. So let's test this fluid. We're going to submerge that in there and press and hold the switch. Heating fluid. Boiling point is 356. It tells us our minimum specs for .3, .4, and .5.1. So 356, we are well within spec. We are right at the minimum for 5.1. We are within spec for .4 and .3 specifications. This fluid in this system is .3. So there is a big difference between the way this test fluid compared to how the electronic tester works and compared to how the test strips work. Both of the electronic and the test strips measure copper. It's not actually testing the safety level of the fluid or its boiling point. This tool will actually determine where that fluid is going to boil by heating it up, by heating up a sample and measuring that point at which vaporization occurs. Then it actually displays the different specifications for .3, .4, and .5.1, so you know, without having to look up any specifications, this tool gives it to you. As more and more facilities and service centers and shops start using something like this, it's going to lead to a lot more accurate testing of brake fluid. Most shops, most technicians have something like this, or the test strips. A far superior method, not common in industry. Unfortunately, this is not something that is gaining traction yet, and I'm hoping over time that this becomes a more popular way of testing brake fluid because it is more accurate. What I want to show you next is an example of how these fluids mix together. .3, .4. This is a pretty simple experiment. What I'll take is some .4, this is the exact bottle that I used, and I'm going to pour it into the .3 bottle. So let's watch what happens. Nothing too spectacular, it mixes together. .4 and .4 Super Racing Blue mixes together. There's no separation. So these fluids all mix together, and I could put this into the .3 and it would all mix together. The main difference here. What should we do? .4 or .3 mixed with .5? Doesn't really matter, they all mix together. Let's do .4. This is an example of how two fluids do not mix. There's a clear separation. So dot 5 is silicone based and it's dyed purple. The racing blue dot 4 is compatible with dot 4 systems. So it mixes with dot 4 and that blue does not separate, indicating that this is mixed. So dot 4 and dot 4 is super blue racing. Dot 4 and dot 3 mixed together. Dot 4, dot 3, the super blue, and silicone brake fluid do not mix. The seals for these systems are designed to work with the fluid that is specified. So if the system is using dot 5, the seals in the system, the seals and the O-rings in the systems are compatible with silicone. If it is specified for use with dot 4 or dot 3, they are glycol based systems, and the seals and the O-rings in the system are made to be compatible with that fluid. We could even take it a step further with dot 5.1. And we have dot 3 and dot 4 mixed into this container. And those are all mixed together. They're all compatible with each other. So which fluid do you use in a system? When should we use dot 3? When should we use dot 4? When should we use dot 5 or 5.1? What is going to tell us that information? Service information. Always check specifications, fluid specifications and service information for the vehicle that you're working on, so you know exactly what type of fluid you're putting in there. If you are trying to find what is wrong with the system and you suspect the wrong type of fluid in the system, there are some methods here that you can see whether or not that system has the correct fluid in it. I'd like to wrap up this topic by talking about how to clean brake fluid. It's a water-based fluid, and a lot of times it will rinse off with water. So if you do spill it on paint, using light soapy water, Dawn dish soap is a great all-purpose detergent for many different things and works great, and it's gentle. So using a little bit of soapy water to clean off a painted surface is probably the best way. For the other components that we're working with, working on the bench, with working on different components, we can use something like this. I get this from Napa. It's made by CRC and it's brake clean. It's designed for cleaning brake parts. This one is the strong formula, meaning it has chlorinated solvents in it. And chlorinated solvents are outlawed in certain parts of the country, mostly because their vapor is toxic, and when it combusts, it creates phosgene gas, which is a nerve toxin. So be very careful when working with something that may have chlorinated solvents in it. There is a version of this that does not have chlorinated solvents. As such, it doesn't clean as well. Now that can be put into a container like this. This is a pressurized container. It has a Schrader valve on top. It has a trigger handle to depress and a nozzle on the end of it. And depending on how much pressure is inside, sprays the fluid out without having to use an aerosol container. Better for the environment that way, and you can buy a bulk product like this and just refill this and charge it with some air pressure. In the tool room, we have a different style. It's the same principle. It uses a different type of brake parts cleaner solvent, and the canister charges with pressure and has a nozzle on it to spray. So thank you very much for joining me for brake fluid.